And the distance from here to here is 35 millimeters. Okay. So that is the information that we know. Okay. So from here, we are going to calculate. I'm going to break this down into 2 columns. One side for element A, the other side for element B. Okay. So the easiest thing to do now is normal stress. I repeat again, the easiest things to do is normal stress. Okay. So this is for element A. Over here is for element B. Okay. So the first thing is due to axial load. Okay. So it's going to be stress Z is equal to, so the axial load is going to induce a compression. So it's equal to minus Px over A. The Px that we found is minus 100 times 10 to the power 3. The area is given as 5320 times 10 to the power minus 6. Okay, so this is equal to 100 power of 3 divided by 5320 power minus 6 is equal to 18.797 minus 18.797 times 10 to the power 6 Pascal. Let me do it again. Minus 100 power 3 divided by 5320 power minus 6 is equal to minus 18.797. Okay. So this is also due to the axial force. Okay, you know what? It's the same thing. Okay, so I'm going to just copy and paste. Okay, it's exactly the same. Okay, next is the tricky one. Next, we are going to analyze due to the bending moment. Right, so the formula, still stress in the Z direction, so it's going to be My or Mx over Ixx multiplied by Y, My over Iyy multiplied by X. Plus or minus, I don't know yet. Okay, we are going to find out. Okay, so let's focus on element A. I repeat again, let's focus on element A. So you go back to, so let's look at Mx. Okay, so Mx, okay, Mx, element A is going to be what? Tensile due to Mx. Okay, so you come over here, it's going to be positive. Okay, then you go back, you look at My. My is going to be what? My, right? My element A is going to be what? Negative. Yes or no? So you go down here, just put negative. That is why it's so important to do the what? Analysis ahead. Yes or no? Or not, you get lost, I get lost. Then I deduct mark is like Canada taking away your income tax. Right? Income tax is very high. Yes or no? Okay. So from here, we find what is our Mx value. Okay, so our Mx is equal to what? Mx is equal to 22750. 22750. So it's equal to 22750 divided by Ixx. We know it's 40.8 times 10 to the power minus 6. Now, the next one is the y distance. Okay, so what is the y distance? So we know this transformation, right? Along this side is x, in the vertical is your what? Is your y. Okay, So we are looking at our y distance. So d is 0.205 divided by 2. Okay. So that is your y. A lot of times students make mistake is what is your distance. Okay, that's where mistake is commonly made. Okay, so then minus what is the my? I don't know what is the my. My is equal to 9600. Okay, so it's 9600 divided by IYY, which is equal to 9.03 times 10 to the power minus 6. Then the x distance, right? X distance is along left to right is your x distance. So we know that this is 75, this is 0.166. So it's equal to 0.166 divided by 2 minus by 75 times 10 to the power minus 3. Oh, this is very bad. I do apologize. Let me move it a bit. Yeah, so this is, come on, Eugene, come on, seriously. Let me just cancel off. Minus by 75 times by 10 power minus 3. Okay, because we want to find the distance from here to here. Right, so from here to there is 0.166 divided by 2 minus by 75 times 10 to the power minus 3. Okay. So this will be equal to 22750 times by 0.205 divided by 2 divided by 40.8 power minus 6. So it's good 57.154 times 10 to the power 6. Let me do it again. 0.205 divided by 2 times 2750 divided by 40.8 power minus 6 is equal to 57.154 minus by 0.166 divided by 2 minus 75 power minus 3 times by 9600 divided by 9.03 power minus 6 is equal to 8.505 times 10 to the power 6. Let me do it again. 0.166 divided by 2 minus 75 power minus 3 times by 9600 divided by 9.03 power minus 6. 8.504. So this will be equal to 57.154 power of 6 minus 8.505 power of 6 is equal to 48, positive 48.649 times 10 to the power 6 Pascal. Okay. Let me do it again. 47.154 power of 6 minus 8.505 power of 6. 48.649. Okay. So now we know that stress X is equal to minus 18.797 times 10 to the power 6 plus by 48.649 times 10 to the power 6. So this is equal to 18 minus 18.797 power 6 plus by 48.649 power 6 is equal to 29, positive 29.852 times 10 to the power 6 Pascal. Let me do it again. Minus 18.797 plus by 48.649. 29.852. Okay, so that's our normal stress. Okay, now we look at element B. Okay, oh, Z. Thank you. I make mistake over there. Okay, so now I'm going to copy the same formula. Okay, for element B now. Okay, so now we look at element B. We look at mx for element B now. Okay, so element B, mx for element B, mx for element B is equal to 0. Okay, because moment about x is at the centroid, so we know that mx, this whole term is equal to what? 0. My is going to have a tensile. Can you see that? Positive. Okay, so it's going to be a plus down here. This one is easy then. Okay, so my, the moment are always the same. So my is equal to 9600 divided by 9.03 times 10 to the power minus 6. X, the x at B So x distance is going left to right. Okay, so at B, so it's equal to 7.24 times 10 to the power minus 3 divided by 2. Okay, 7.24. Okay, so this will be equal to 9600 multiplied by 7.24 power minus 3 divided by 2 divided by 9.03 power minus 6 is equal to 3.84, positive 3.849 times 10 to the power 6 Pascal. Let me do it again. 7.24 power minus 3 divided by 2, 9600 divided by 9.03 power minus 6 is equal to 3.849. Okay, so from here, stress Z is equal to minus 18.797 times by 10 to the power 6 plus by 3.849 times 10 to the power 6. So this is equal to minus 18.797 power 6 plus by 3.849 power 6 is equal to minus 14.948 times 10 to the power 6 Pascal. Say it again. X. So the x distance over here is 7.24 times 10 to the power minus 3 divided by 2. Yeah, right side of the centroid. So on the right side of the centroid, yeah, it has to be divided by 2. No. This distance here to here is 7.24. Element B is here. So it's on the right hand side. So this distance 7.24 divided by 2. Right? Make sense? Okay. Right. So the next thing that we're going to do is the shear. Okay. So far, so good, right? It's not that bad. Am I right? Now it's just plugging in what you know. The difficult part, or so-called one of the most complex part, is identify your moment, your axial load, your shearing force. Now it's plugging in the force. Next is the difficult one, shearing stress. Yes. Where is 18.797? This one. That's the axial load. Okay. Okay, so the next one, we want to look at Vy. Okay, so from our analysis, Vy is equal to 25 times 10 to the power 3. Okay, so I'm going to copy this diagram. I need this diagram now. Okay. So one is for element A. The other one is for element B. Okay, one is for element A, one is. So the formula, because we are doing Vy, okay, so shear stress is equal to Vy over Ixx Qx divided by T. Okay, so let's see what we know. Okay, so we know that Vy is equal to 25 times 10 to the power 3. We know that Ixx is equal to what? Ixx is equal to 40.8 times 10 to the power minus 6. Right? The thickness is your what? TF. Okay. TF for element A, TF is what? TF. 11.8 times 10 to the power minus 3. Okay. The critical part is how to get Qx. Always the first moment of area is our problem. So